All right, let's go over what we talked about in class on Friday and also as a helpful review of the concepts in the 11's lab in the first two activities. So we had these goals set out. I can secure my class variables with encapsulation. It's a standard practice that we all need to learn as good programmers. I can create a constructor to initialize an object. Whenever we instantiate something, a process called initialization takes place. There's a lot of complex words for something that's actually not too complicated, but we'll go over it. I can override a parent method. We talked about this with the toString method that we're using, and we'll look at that in a second. And I can build unit tests for all methods in an aggregate object. This is a mashup of two concepts here. Unit tests, which again is just a responsible way to go about programming an app. So it's important that you guys learn this. Even though it's not as heavily focused on the test, it's still nonetheless, if you do any programming, and even in the major projects here, it's helpful sometimes to really lay out the tests first so you know you're getting it right and you don't build on on a broken foundation. And anyway, so the aggregate object idea is actually really simple. We just made a card, and now a deck is a new object, but it has 52 of our other objects in it, or we can make more or less than 52 if we wanted. But that's the idea, is one custom object inside another custom object. And so we'll talk about that. All right, so encapsulation. Let's get right into it. I'm just going to zip right down these slides and try to show examples from our code. So encapsulation is the idea that all of our variables are kept as private. So you can look at the card, for example. So when we create a card, it stores the suit, the rank, and the point value of that card. Ace of clubs with a point value of 1, as it's an ace. We keep all of these instance variables private. And it's an instance variable because it's listed outside of a method right underneath the class header. And so that you have the class header, you have your instance variables, and then you have your constructor. Right here we have all of these instance variables being declared as private. And that means over in our deck, if we needed to get, to test a value of one of these cards, see if its rank is an ace or whatever, we can't just do card x dot rank. We can't access that. What we would have to do is make an accessor method like this that you just call rank with parentheses, which activates a method, an action, and that action just happens to return the rank. So you can't now edit the rank, but you can call a method that returns a copy of it. So that way you are able to access that information, but not edit it. And that's encapsulation. Not too difficult an idea. Let's hit the key terms again. So we have encapsulation, the idea of keeping your instance variables private and secured. And in order to access them, to get at them, you go through accessor or mutator method. An accessor method, as you can see in this method header, this is its return type. It's just going to return your health if we're making a player in a game then. And a mutator method, let's say the player took damage and you need to set its health to something lower, then you can call this method setHealth, and it doesn't return anything. However, this time it takes a parameter, and that way you can set the health to the new health value that's coming in here. Okay, so mutator and accessor methods. And if that isn't clear, now it's on you to come speak with me after class or send me an email or something like that, and we work it out. A constructor is a method with the same name as the class. So if we have the card class, then we're going to have a card method. So here's the public card method, and it's inside the public class card. And so when you create a card, as we did here in this card tester, you declare that, hey, I would like to make a card, and its variable name is going to be that. It could be what I could make it X if I wanted to. It would be the same, no difference. But we use camel casing to label our variables like so, just so it's easier to understand what it is. If I see something that's capitalized, then I know it's a class. I know it's an object. But if I see something like this, then it's just a variable that I'm using and not a declared object. So yeah, I'm not gonna go too far into that. If you have any questions about naming conventions, let me know. But the new keyword is what I really need to emphasize here, and that's when we're instantiating an object. When we want to call its constructor, we're making a new one. Put this together, construct this for me, and we're calling its constructor, and we're passing these variables to it. So this, you can see it's a string, and an integer. And if I look over here, guess what I'm going to see? A string, and an integer. Really, it's an int. There is such a thing as a capital I integer that we're going to learn about. But so I should be more clear. It's an int, not an integer. So you have these three things, and all that this does in the process of instantiation, i.e. making a card thing in memory, in the process of setting up this set of data, we need to initialize its values, set up its starting values. So instantiation includes initialization. So this is the process of instantiation, and setting these values we're initializing the values. And so rank is this dot rank is referring to this rank, so this card's rank. And if I don't use the modifier this in this particular example, it will refer to the local variable. You can see how I click on it, it recognizes this as the same variable as this guy over here. But if I click on this one, it doesn't highlight, because it's looking at the instance variable now. Because it knows that if I'm using this, I mean over here. But if I'm not, then it will just assume the local variable that's being set up here. Okay, that's a question about the keyword called scope. All right. We gave an example in class, just to review this one more time, about how would you instantiate a willow tree. And so you can see that the class is set up here, public class tree. Extends plant is referring to inheritance. We'll talk a little bit more about that. You as a human inherit all of the properties of a mammal, and so you would extend mammal and have all sorts of, so I wouldn't need to double program. I could just make it efficient. The common elements will all be in there. We'll talk more about that later. But when we are creating a new tree, we need to activate this constructor and initialize the starting value of the species. So if I was going to write that out, I'd write, so I would like to make a tree called X whatever, and it is going to be a new tree, and if you, as you can see, I need to provide it a string for the species that I would like it to be. So I'll just say willow, and now end semicolon, because you always have to end it in a semicolon, and ta-da, I made a tree, and it's a willow tree, and that's its private string keeping track of its own species will now be initialized to that value that's being passed in through this variable. The constructor can also be overloaded. which means you have two methods of the same name, but they take different parameters. So if I told you to clap without giving you a number, you might assume, okay, that means I should clap twice. But if I said clap 3, I'm being more specific, and now you're activating in your own head a different sort of clap method that takes additional instructions and will loop the clap process that many times. However, whatever integer I give you to clap, you'll loop that many times in clap. So the same thing can be done with a tree. So if I want to make such a tree, I could go tree x equals new tree. Now, instead of providing the quote willow, if I have no parameters, this one will be activated. So all I have to do is end parentheses and semicolon, and now this one will be activated, and its initial value of species will be set to willow by default. So a new tree by default in this script is always going to be a willow, unless I were to make a tree y equals new tree and then oak. And now that would activate this constructor, because this one takes a string parameter. Oak would fill in this variable, and that would be set up as this tree's species. So I'd have two different trees in memory now. One whose species variable would be set to the default value of willow, and the other one who would be set up as oak through a different constructor. Okay. And the last really major concept, these other two are super simple, is the override option. Now everything has a toString method. So all objects in Java have a toString method. So let me show you what I mean. So take, for example, if I print this card's toString method. It's built-in toString method. So I made a card, and I'm just printing out its toString. I get this crazy value. It's card at this location in my RAM. And so that's its address in my stick of RAM. And that's not very helpful if I'm trying to test to see if this card was set up correctly. And so if I go back over to card, we made this thing and we overrode the built-in toString method. And now when toString is called, it will access its rank and put it together with a whole little sentence to print out its rank. And so if I run it now, the toString method that's built in that gives me that silly little bit of information is now replaced with something much more relevant and helpful to me. And so I overrode that method. And so that's why we put this little decorator. It would still work without it. This would still work fine, but it's not best practice, so it still works. But it's not preferred because of a couple reasons. One, so that I can understand that this is overriding a method, and so I can look at that method. So this is the actual Java object. So this is now looking in under the hood of Java, and you can see a lot of crazy stuff in here. So do look through this. It's pretty neat. But it's just a note that, hey, there is more behind the scenes that I'm overriding here. And that's helpful for new programmers to understand what you're doing in your code. And it also improves the compile time, because now when you're putting your app together, you're giving more cues to Java as to how to build your app. Okay, so fun fact about this toString method, you can call it implicitly. I don't need to have that because I'm printing this variable. It dynamically will automatically call the toString method because this method expects the string. So Java will fill that in for me. Pretty handy. And all this stuff that we have in this file, by the way, are the unit tests. Every little unit, every little method, every little bit that we made in our app, we're testing each little thing. And that's what a unit test means. And so we're building out our tests first, and that way we can know if we built the